Dennis, I'm going to give you the mic. Take it away.
Gosh, we're running quick ahead of time. I'm really pleased to see so many people come out tonight. We've got a good program, and we strive to do that throughout the year. We do have some standard programs like Field Day preparation and Hamfest preparation. But the other months, we try to get something in there. If you know of something you'd like to have put in there, please suggest it to me. And if you know of a source, Justin here actually was telling me about his little mobile radio direction finding rig down at a memorial service of one of our members who passed away this past year, and I said, gee, that's neat. And when I started putting together programs, I asked Justin, I said, how about doing that? Sure. So, that's how we get good programs. If you know of some, we'd like to know about it. Justin has been interested in this for some time, at least a year or so. Haven't talked to him in depth, but I think you'll enjoy the program. And I'm going to turn out some of the lights so you get a little better contrast on the screen behind it. And I hope you enjoy the program. Thank you.
Thank you, Dennis. Good evening, everybody. My name is Justin, KO4CEQ. Let me make sure I'm not blocking the screen here. So I've been in it a year or two because I haven't been in ham radio really all that long. I got licensed in February of 2020, just before the strength of COVID hit. I got sick during my daughter's birthday weekend. I ended up not interfering with that weekend trip, so I sent the wife and kid away, and I had the weekend alone by myself, and I'm like, all right, well, I need a new skill set. And I had some Baofangs sitting around that I had bought a year or so prior for basically the only other reason anybody else buys a Baofang, the whole just in case thing. So I sat there, was fiddling with the radios, tuned in a couple of repeaters, and I decided, you know what, I might as well do this. So that weekend I ordered the ARRL study guide for the tech, and shortly after their general, I got them both knocked out pretty quickly, and knocked out my tech in general in February of 2020, and then I followed that up and I finished my extra in January of 2021. So, but shortly after I got started with ham radio, I ended up having an issue, mostly on HF, not so much on VHF, UHF, which is what this applies to, but HF, I started having an issue. I had really bad noise, and I suspected it to be power line noise, and Phil was generous enough to come out and help me, and thus started the dive into direction finding, because we wanted to figure out the source of that noise. It ended up being two separate transformers, well, one lightning arrestor, one transformer, completely opposite each other, about a block and a half each in each direction from my house. Crazy situation that both of them were bad, causing a high noise floor for me. But I was able to work with, again, Phil, and then Dan for GK. He put me in contact, and he kind of guided me into getting the process started with FPL to have that corrected. And I think from what I understand, that was kind of the impetus to start the RFI committee up again. So I'm grateful something could come out of that positive. I'm not directly involved with that. Hopefully this little bit of information can help with that if the committee deems it ideal. But anyway, I'll want to give just a heads up. This will probably be a little bit shorter of a talk than what's usually given. I've got an extra class license, but I put paper in a box for a living, work for the post office. So I'm coming at this and giving you guys my experience from a appliance operator standpoint, if you will. I didn't design this. I don't know the software intricacies of this. I can give you the basics on what I have, but Dennis was really eager to hear about this, so I figured I'd put this presentation together. So we'll go ahead and get started. Now, it's a little bit about me. I got licensed in February of 2020, basically everything we talked about. So I had been interested in the basics of radio direction finding and what really piqued my interest as far as the VHF UHF side was March of last year. We had Jeremy Hong, KD8TUO, give a presentation. I put the video up of the presentation up on my YouTube channel. It was hacking in ham radio. And he is no longer here with us. He took a very generous offer to go back to Ohio, I believe it was, and we're hoping to bring him back. But if you guys don't remember Jeremy, this is Jeremy. Awesome guy, brilliant, and we miss you, buddy. All right, so I'll go ahead and get and dive in. And what is the KrakenSDR? It is a coherent software-defined radio, and it uses 5 custom RTL SDR circuits. You guys know the dongles that you can purchase pretty cheaply for, you know, 35, 40, I think, you know, I don't know, 50 bucks now since the price spike. You typically just plug them into the computer, hook them up to a radio, and they can receive over a wide bandwidth. Well, this is it's a lot more than just 5 of them crammed into a box. They're driven by a single clock source. They also have like a noise source in order to calibrate off of, and it allows a phase relationship of each RTL SDR to be measured precisely. The frequency range that is advertised for the Kraken SDR is 100 megahertz up to 1 gigahertz. Now, I've been told that it is possible to go lower in frequency than that, but as we'll get into later, the antenna arrays need to be set up according to the frequency that we're going to be using. Just like our antennas, the antenna arrays need to be set up accordingly, and that when you're getting below 100 megahertz, it ends up being very, very large antenna arrays. So this works very well for VHF UHF, which in my experience, the magnet mounts that they sell, you don't have to use the magnet mounts. You can create your own, although you have to be very precise with them in making sure everything is exactly the same for each antenna system for each RTL SDR inside of that Kraken is exactly the same, as close as possible. So, but these, the package that they sell come with little magnet mounts. You can slap them on top of the roof of the car and they work beautifully. But down to about 100 megahertz is basically the sweet spot. So it does use the open source core DAQ and DSP. The DAQ is data acquisition software. Both of those run on a Raspberry Pi, so you will need that. The Kraken SDR basically takes that information of the signals being received and it feeds it to the Raspberry Pi. The Raspberry Pi is what actually does the heavy lifting of figuring out which direction it's coming from. Now, the radio direction finding, not just the Kraken, but it has a whole bunch of different uses. You can use them for fox hunts, both for fun and games, but also to locate pirates. I know is Ken in here tonight? No. Oh, is he? No.
You're safe.
Oh, I'm safe. Okay. So, no, but I know we've had an issue in the past, and up till very recently, I get notifications from him all the time. He's asking me, but every time he gives me a frequency and an incident, I'm always at work, so I can't really drop things and go track things down. But as far as companies using the bands unwittingly, illegally, it can help us figure out who's doing that and help us educate them on proper use of the frequencies and helping them guide them to maybe something that might be a little bit more better suited for their scenario and a little bit more on the legal side. So here I've got just a breakdown of what is inside the Kraken SDR, that board. You've got SMA, antenna inputs, a bias T, an ESD protection, noise calibration switches, a couple of other things listed there. It's a fairly simple device. I've got it here inside the Pelican case. I did jerry rig antenna connections to the outside, so I can't just pull it out of the Pelican case right now without making a huge mess, so I'm not going to do that. Y'all are more than welcome after the presentation or after we're done during the break to come up and look and poke around on it. It's not super pretty, but it's what I got. So in order to run the KrakenSDR for radio direction finding, you need obviously the Kraken. You will need a 5-volt, and this is super important because I've run into issues with this before, a 2.4 amp USB-C power supply, and the Raspberry Pi 4 also needs about 2.4 amps. I have had a number of issues in the past where, you know, I use a little cigarette USB power, and it's got 2 outputs, and those often advertise, oh, this is 3 amps or 3 amps, but it's dodgy. It may be total. It may be total and not individually, so you can have some issues there. I like to just run 2 separate power bricks, just battery banks, so I know I'm having that power. It's dedicated. I get longer battery life, and I don't have to worry about hitting a bump in that cigarette lighter plug, just jarring loose and then losing everything. So you'll need the USB-C to USB-A cable to connect the KrakenSDR to the Raspberry Pi, and a 5-element omnidirectional antenna array with identical transmission line. It's super important because of the way the signals are received and translated. The Raspberry Pi ends up, and the Raspberry Pi calculates the phase difference that each antenna is receiving. And so you need to make sure that each one of those transmission lines, that coax, is super accurate down to a T, more so as you get closer to the 1 gigahertz frequency range. And optionally, you can use an Android device for mapping. So we'll talk about the mapping is a super cool feature, and I'll talk about it in a little bit. You will need a separate device, though, other than the Raspberry Pi. I was a little bit disappointed when I found this out, that you can't actually look at the bearings that it gives you through the GUI directly on the Raspberry Pi. I went and I bought a screen, and I installed the screen, hoping that the GUI could open up. It was a touch screen, big fancy. I spent, you know, dozens of dollars on this screen for the GUI, and didn't work the way I wanted it to. It just basically ran the script. It showed me the script it was being run, and that's about it. So you will need something to basically Wi-Fi into the Raspberry Pi in order to view that, but also the Android device, they have an app, and it is really cool. I'll have screenshots of it shortly. So antenna setup and placement, again, we got to make sure that coax is basically identical in length. If you buy the antenna array that they sell, it comes with a set of matched coax cables from the same batch, because you can have coax, even though it's the same length identically, if it just small variances in the way it's made, the dielectric can cause different velocity factors. It's good to have everything in the same batch, but they sell the array with the antennas with basically exactly what you need. So there's a couple different ways to do it. You can use a uniform circular array, which is kind of displayed up on the screen. The antenna 0 will be facing in the direction of travel, or that will be your 0 bearing point. Or there's the uniform linear array, and that gives you 180-degree tracking. It is more precise in as you get to the center of that array, if signals are arriving at a perpendicular angle of the linear array, you get a little bit more accuracy than you will from the circular array. However, it doesn't know if the signals are coming from in front of you or behind you. So if you're traveling around and you're trying to use this in a mobile application, it's really recommended. The circular array it's the way to go. So they have a file on their website you can download, and it's basically just a simple Excel file, and it gives you the calculations that you'll need. So everything you need from the radius to the antenna spacing. Radius being the point at your basically center point right here. This is basically what I go off of when I'm setting up my antenna array. The most important aspect, though, is your spacing of the antenna elements. I have found that, though, as long as excuse me, as long as you're close enough on the radius, you will achieve that inter-element spacing, and that shouldn't be an issue. What I've done, and I'll show you, I've made up little reference cards because my ADD, I like to jump from thing to thing, and I actually haven't touched this in a couple months. And I pulled it out a couple weeks ago when I was putting the presentation together to start fiddling with it to kind of figure out what I was going to talk about. And I'm so thankful I made those reference cards because it gives me the spacing that I'm going to need for the frequencies that are most commonly used, and it gives a fairly wide range of frequencies for a particular spacing, but you will definitely need two different setups for UHF and VHF. You won't have one that will cover either, but you do have a bit of leeway with each. So antenna setup and placement, here's the other picture. So you can determine it based off of the frequency that you're going to be using, which was on the last slide. This slide gives you, you say, okay, well, I'm going to use this particular antenna radius, and it will give you the spacing multiplier, the frequency, and the estimated resolution. The estimated resolution is how accurate you can expect those readings to be on directionality. So the closer you get to a half wavelength in your multiplier, you can see right here. So at a radius of 25 centimeters, your spacing multiplier is 0.5, so frequency is 510 megahertz. You will have about approximately 8 degrees when you receive a signal. And the lower you go in that multiplier and the frequency, so you can see right here, the frequency covered, you can accurately DF between 510 megahertz down to 204 megahertz. However, as opposed to the 510 megahertz where you had 8 degrees of accuracy, when you get down to 200 megahertz, you've got 20 degrees of accuracy, which can be kind of iffy. If you're running the Android app though, as you're driving around, it will do triangulation on its own and give you some pretty good results. So I got a couple of pictures here from my truck. I started off with a template, again, offered on their website. I printed it out, felt like a 6-year-old again. It was amazing. There's a couple of printouts for your antenna array spacing. Again, this is for the smaller frequencies that you use. However, I found this great for the larger frequencies as well, because this did not cover, as you can see, the spacing for I didn't take a picture of it, for my whole truck, the top of my truck. So I want to say this one here, I've got one up there, and then matching on the other side of the truck is for the VHF section but you can't get that with this. What I did though is I just literally took a magnet, put this down on the center of the truck, and took a piece of measuring tape, and I just went out and then I put just a little piece of painter's tape on the roof of the truck. I got a tall enough truck. It's like 6'7", 6'8", something like that in height, so nobody's ever going to see that blue painter's tape. And if I want it to come off later on, I can peel it off and, if necessary, use some Goo Gone, and that will be all I need. So I've got tape up for VHF, and then I have here displayed my setup for UHF. So this is what I use for the GMRS and 70 centimeter bands. I did go ahead and color code each cable, each piece of coax, simply because I have found when you're dealing with a whole mess of wires, figuring out which antenna goes to which port can be a pain in the butt. So something that's easily referenceable is color, unless you're colorblind. Thankfully I'm not. But I can just take a quick peek up at the hood, and I said, okay, this position, orange is in position 0, 1. So I go the other side, I take that orange piece and I plug it into port 1, etc., all the way around. let me see here. Did I cover everything? Determines radius, template cutout, spacing will be close enough. Yeah, you know, referring to that, the spacing will be close enough if using this method. I've seen online when I spend my money, I like to do these little deep dives into it. I want to know exactly how to use it. I want to squeeze every feature I can out of it. And I came across a number of videos and, oh, you need to be precise down to the millimeter. I will tell you, good enough. I'm an 80% guy. That may sound terrible, but I want the 80% solution because I know to get that 100% is going to require just a ridiculous time, effort, money, etc. to get to that 100%, and it won't be worth that. I won't get my return on investment on that last 20%. Give me what's good enough, and I'm telling you that's what's good enough. Take that, slam these on top of your markings where you've marked the painter's tape, and you'll be good to go, barring some major impact that knocks the antenna several inches off of where you installed it. So here I've got to set up just basically how that flow of information and the signal gets from the antenna over to your computer or your Android device. You've got the antenna, feeds it via those 5 connection ports into the SDR, and then via USB-C into the Raspberry Pi. It gets calculated. That Raspberry Pi, I don't know if I put that information in here. The Raspberry Pi sets up a Wi-Fi network, its own Wi-Fi network after 2 minutes, if it does not detect another Wi-Fi network to connect to. So what I do is I start up a mobile hotspot on my phone so I can use my phone's internet data while I'm cruising along. But in the absence of that, you can just turn on your Wi-Fi and wait for the Raspberry Pi to create the Wi-Fi network, the KrakenSDR Wi-Fi network, and then install it, and then connect to it there, and then run as you would. On the app, you have the option to download those maps for offline use, and I've got the maps of the area as well. It doesn't take up a terrible amount of space. Do I have any questions so far?
Is the 4P
Yes, sir.
the lowest model of Raspberry Pi that will do this?
Is the 4P the 4B? Yes, that is what they recommend, 4B or later, just because the earlier Pis don't have the processing power to keep up. They do have an image. They have an image on their website that you could just download onto an SD card. You plug in the Raspberry Pi, and you're good to go. Again, I'm not a software guy. I drag my knuckles everywhere I go. So, great question though. All right, so connecting to KrakenSDR with a mobile hotspot. I just briefly discussed on this. The Pi will look for a mobile hotspot, and with the Kraken Android as a network name, and automatically connect. Make sure that you're not having any interference with 5 gigahertz Wi-Fi. And we talked about this already, the offline mode. And in the app, okay, so if you download the app, first thing you go, I've put it on the card, the reference card, if you guys want to come check it out later, step by step, because you do have to do some fiddling. Not ideal, but it is what it is. You need to, if you connect, excuse me, if you have the Raspberry Pi connect to your phone as you're running the mobile hotspot, when it connects, you will need to find the IP address and then enter it into the settings so that you can access the GUI through the phone or the Android device. If you wait for it to connect, you will have a standard IP address that you'll need to put into the settings to reach into the GUI. So speaking of the GUI, here we go. This is the first page when you get loaded up that you see. On an Android phone, it's more vertical. All those boxes are just stacked on top of each other. And this one, all right, so that's a little bit cut off, but we'll work with it, we'll go. So what are the big things here? I'm not gonna hit on every single feature or thing we've got here. So the big things to look for when you start it up, you want green basically all down that side. Now, occasionally if you get a loud noise source or something that's very proximate to you, somebody's transmitting is very proximate to you, it's desensing the receiver. You will see that overdrive. I took this shortly after it was booting up, so it was just kind of what it was going through. You see the center frequency. One thing to take note of is the VFO power. So typically down here, it'll show you what the noise level is that it is currently receiving. And that will determine what you set your squelch at later on down the road. Is it on here? Did it make it onto this screen? I don't think it did. Okay, well, so that's an example of what's on the Android. That's completely illegible right now. So, but you can see up on the right, you have actually a waterfall display and a pan adapter that you can use to kind of hunt and peck and find where the signals are within a certain frequency space. Is that it? Nope, there we go. All right, so a huge benefit of using the KrakenSDR with the Android app is the mapping feature. So we've already we've already talked about how the Raspberry Pi is what's doing the heavy lifting and determining the bearing where the signal is being received from. The map calculations are done on the Android device itself. So it takes the history, it starts recording all that data that's being received, and it takes the history of that data and then starts plotting out on a map, assuming you are traveling in a particular direction. Now, it will pause. You have the ability to turn it off. I don't, but I would keep it enabled, simply because if you're driving, what happens when we get to a red light, a stop sign on our GPS when we're driving? The GPS starts thinking we're going this way, and we're going this way, and we're turning around this way, all within a couple seconds. So if you're still receiving that DF data, that can completely skew the results. Now, the app has the ability to just, hey, below 2 miles an hour, pause plotting, and it'll pause the plotting. So once you're back up to speed and you have a decisive heading, it'll go ahead and resume the triangulation. So it uses this, and you can kind of see the overlays. You've got the multipath lobes, and it uses, it doesn't use TDOA, it uses the phase coherence. It determines the direction using phase coherence in order to determine the path, and also takes into consideration the multipath. The way they describe it on the website, completely over my head. I'm not going to try and, convince you guys that I know what they're talking about, because I don't. But it takes that data, it is able to plot it, and after a short time, it will actually give you an idea of where it thinks the transmitter is starting off. And when it starts, you'll see the shape right here, but it'll be red when it says, okay, this is where I think it's at. And it'll, if you want it to, just like a GPS, you just say, give me directions, and it will plot street by street, turn by turn, and bring you in that direction. As it becomes more confident of the result, it will turn green. And as you can see, it gives you a heat map. As you continue to get more data, get closer to the source, it will tighten down that heat map to a singular spot. I think it's super cool. I still want to try it with actually coming down Palm Bay Road over in front of like Wawa. I got a lot of RFI on 146. So I actually might do that my next day off on Friday or Saturday. I might see if I can use it for RFI instead of just individual signals. But that's basically how it's done. Excuse me. So, any questions as of yet? Yes, sir.
Just explain what's on the left screen. Kind of hard to read, just sort of what the key points are.
All right. So right here. So again, like I said, it takes the multipath signals and it kind of calculates that into its heading. Right here, the circle here, you've got this. It says hill. So you've got multipath coming off of that hill. and then multipath lobe caused by hill reflection, and this is the main lobe. Direction of the max lobe energy and the clearly main lobe. Some of the stuff is self-explanatory. Forward direction, and the red line is a forward direction of the antenna array, and this is the known transmit location during a test. This is not something I did. This was something I pulled from their website. So yeah, cheat sheets. What I can do, if anybody's interested in this kind of stuff, and if anybody is wanting to go out and get it, I got this simple document. Go out, print it, and I've got on here, I can pass these around, the antenna array radiuses and what frequencies they're good for. I don't know why that's so expanded on there. All right, so getting into my setup, I do, like I said before, I do use a Pelican case, and I drilled, let me tighten this down real quick, or take this out. Doing it on the fly here. So just so that I'm not having to fumble around and take things in and out and set them up and have them flop around the car and all that stuff, I decided to just try and keep it as self-contained as possible. I keep everything inside the box when it's not in use, and what I did do is I did get a couple of connectors, drilled a couple holes in the appropriate spots right through the box, so the KrakenSDR can stay in the box. I don't have to have wires fiddling around. I have tried to run it. While it was closed and sealed up. After a short while, I got some limited results. I'm assuming because of heat buildup within the case and the extra foam padding. There's a number of different other setups I've seen people run online. Some of them have 3D printed brackets and then put them on a piece of plywood or something like that, and then kind of put some straps on and then hang it from the passenger seat. So it kind of just hangs there, decent airflow. But then in my opinion, I thought about doing something like that, but then I've got a bunch of wires, I've got a bunch of parts and it just sits out exposed and not ideal, especially with the wife and kid. So, all right, well, that's about it. Went a little longer than I thought it would, honestly. But anybody have any questions? Yes, sir.
You said the wires that connect up to the antenna have to be the exact length and that they come with it.
Yes.
But that radius needs to change when you change frequency bands.
Yes.
So what do you have to change? Do they give you that or you make it?
I used reliable old zip ties. So I went, and with the largest frequency that I use, I need about this much space in order to get that proper element spacing on top of my car. So I zip tied it over there because I'm going to have plenty left over for VHF, UHF.
That's what comes with it.
And yeah, with the antenna setup. They sell the KrakenSDR is separate from the antenna array. And so, yeah, I just zip tied it so I'm not constantly dealing with a huge mess all the time. Good question. Anybody else? Dennis.
You elaborate on something that caught my attention earlier. I think the one time you tried to make a test run against an unknown transmitter to figure out how long it would take to locate it. What was your experience there? You started out 4 or 5 miles away, and within, 15, 20 minutes, you pretty much figured out where it was.
I've had with individuals that I've had transmit or have been transmitting. Once I've got the frequency, and I have the SDR and the Raspberry Pi, which can take a few minutes, a handful of minutes to actually get set up and calibrated and running accordingly. The GUI can be a little bit slow, but the moment you key, it gives me a bearing, and within, depending on range and distance, a minute or two. And I mean, if I'm traveling down the road in an ideal situation, and I'm a mile or so away from you, and I'm booking it 40, 50 miles an hour down the road, you transmit once, I've got initial direction, and then another minute or two later, and I'm a significant way down the road again, and you transmit another time, you get a secondary transmission, you can get within a block area, like right out there, 2 1-second bursts or less, just real quick. So it's again, the longer it goes, you know, you can be at the transmitter location, and again, depending on how far away you are and you know, distance, it could be a couple minutes. That's it. So you had another question, sir?
Yes, Andrew. I was wondering, does it work only with continuous emissions or will it do intermittently?
Just it pings immediately. The moment it receives a signal, it calculates that bearing and spits it out. Now if there's, again, triangulation is, you know, triangulation, you need different points on a map that are adequately separated. So if without that, I remember, Walt, there was it was last year, we had some sporadic, and we had somebody you were talking to out southwest, and they were like far southwest. They were on the other side of the state, I believe. They were on, yeah, it was on 5.2 or something like that. And I was able to hit, man, I was able to hit it. I heard them talking, and just that beam, that heat map just showed solid southwest. And it was later I was talking to you when I got the location. So, I mean, it's a fascinating setup. It's really cool to play with and super useful. I'm going to be toying around with it a little bit more with RFI if I can find it. There's a place right across the street. I suspect there is a bad transformer right across the street from the cemetery over on Babcock in Southeast Palm Bay. I'm going to see if I can figure that out with that thing. So, yes.
Those little Bionics box transmitters, would you be interested in trying to find it someday?
Absolutely. What's the wattage on that? Like about a watt? How far can you hear it from?
Well, it's limited to VHF, you know, line of sight kind of stuff.
Okay.
You know, by putting it somewhere tall, you'll find it, but if
Yeah.
not, it's more challenging.
So that's the biggest thing is that you know, you'd have to have an initial bearing. Like if you can hear it, you can find it. So I'm not saying that this is going to be the most sensitive receiver out there, but if it can hear it, and again, that's going to be dependent on the antenna array that's being used. This is probably not the most ideal, but there are other better options out there. I don't know if I'm going to invest in those because time, again, 80%. I'm an 80% guy. All right. Yes, Walt.
Just real quick, I know you have a full-size truck.
Yes.
Really nice. You have a compact car, like a Prius or something smaller, a smaller vehicle. Does that affect how the antennas work? Is there a setup to move them closer? Do you have to make changes to that, or how does that work?
So it all goes based off of the radius or the element spacing that you need for that particular frequency. So it is relatively accurate. What they say is ideal is anything over 0.2 wavelengths. So you can go smaller than what is ideal and still get acceptable results. Anything smaller than that, it'll give you a warning message like, hey, this is out of range. Your results, you know, your mileage may vary. Where are those cards there? Can you tell me what it says for VHF down in the very bottom? It should have element spacing. Is it 0.6 meters? 0.6 meters. So, you know, 0.6 meters is, I mean, yeah, I mean, that's radius though. So you're looking, that's where the center of it is. So yeah, you're looking, you know, a little over a meter width. So your limiting factor, and it was limiting for me, is not so much the length of the vehicle, but the width of the vehicle. That's where I kind of, you know, came close to running out of room. Yes, sir.
Transmission lines, how long are they?
The transmission lines, just like everything else, they suggest as short as possible. But the ones they sell, I want to say, are 10 feet, 10-ish feet, yeah. So the lower in frequency you go, the longer they can be. The higher in frequency, you know, just like with anything else, the higher in frequency you go, you want them to be as short as possible. Last call. Okay, a couple more there. I'll go with Phil first.
Volkswagen, the early Volkswagen with the dome top. Get a car carrier, get a 4-foot plywood sheet, mount a steel plate on top of it.
That's no, he
Justin and have him do it, okay?
Phil jokes. He said for an old Volkswagen to install basically a piece of plywood on the roof and then a metal sheet to act as the ground. But there are plenty of people. There are plenty of pictures online where people have done exactly that. They've created a mount to stick, a suction mount to stick to the roof of the vehicle of something that's more dome-ish roof, and then
Go with style, put a couple of surfboards.
there you go. There you go. Super slick, low profile.
Rob's got a good point there. What about all these trucks that aluminum?
Suction cup.
Can you tape them?
So yeah, suction cup. I've seen 3D printed mounts. I've seen 3D printed mounts. I've seen what Phil's been referring to as the plate. I've seen people engineer like a slider where you just make one adjustment and it moves the antennas out appropriately, all at the same time in unison. So, when I get this video uploaded, I'll take examples of that and I'll put them online to kind of, show people what they can do with the options. So, you had one more?
Yeah, I've always wondered what would happen if a dog is chasing a car and if it actually caught it. Because it would get ugly, I think. But you spend all this time, you go out and you find a target, and the technology's cool. Like I was in the Civil Air Patrol, we did direction finding and stuff that was a lot less high-tech than this. What do you do when you find it?
That's the $1 million question. What do you do when you find the target? So it really depends on the person. There are some people that probably shouldn't do anything within this group. We know who we are. Again, the situation will dictate. With almost everything in life, the situation will dictate. If it's if it's a company running. Yeah, don't go out there and yell at them. Don't yell at them over the radio. Don't say, hey, I know where you are. No, just, hey, are you guys aware? Maybe the most tactful approach. I can help you find radios that won't violate the FCC and may not cost you guys a large money to find because, I'm a cool guy. There are some others that will go right to the FCC and try and get you slapped with a fine. There are some times where, you don't want to engage and then go through other methods in order to try and correct the issue. But again, when that dog catches the car, when the dog catches the mailman, sometimes you just don't know what to do. So, bear spray. Alrighty, well, that's it. Thanks for coming to my TED Talk. You guys have a good one. Thanks for being a great group. Thank you. Grab my drink.